Yeah. Uh, Hi all. Good evening. Hope you all are doing well. So today we are going to cover a topic uh, that is mastering memory management for mobile devices from RAM to OS optimization. So before moving forward, I would like to introduce myself. My name is Munish Kumar, and I have almost 10 years of experience in mobile development. I worked on multiple applications in different domains like banking, social networking, and e-commerce. I am working here in Ancora as a senior software engineer. So today's agenda is like we will discuss what is the importance of mobile devices, why we need memory management for mobile devices, what is the role of RAM in memory management, how memory is managed internally, how as an application developer how we can manage memory for mobile devices, and as an end user how we can improve memory efficiency. So that's all we are going to cover. And one more thing broadly, two operating systems are used in mobile devices that are iOS and Android, so we will focus on both. Okay, so first of all the thing is what is the importance of mobile devices. So mobile devices has become an integral part of modern life, and their importance is stemmed from various factors that have significantly impacted the way we live, work, and communicate. So let's discuss few of them. First of all, connectivity. Mobile devices enable constant connectivity to the internet and communication networks, allowing people to stay in touch with others, access information, and participate in global communication regardless of their locations. And communication, mobile devices offer various channels like voice chat, text messaging, social media, email, and instant messaging app, making communication faster, easier, and more efficient. And information access, from news update to educational resources, we can obtain valuable information on the go. And the productivity, mobile devices have transformed the way we work and boosted productivity. They allow professionals to stay connected with their work tasks, emails, and documentations, even when they are away from their desk. And entertainment, mobile devices provide multiple entertainment options from streaming video and music, games, reading books, and engaging with various multimedia contents. And next one is navigation and mapping. Mobile devices with GPS capabilities offer reliable navigation and mapping service, making it easier for people to find their way in unfamiliar locations. And social net connectivity, social media platforms accessible on mobile devices have redefined how we can connect and share our lives with others. And mobile payment, uh, mobile wallets and payment apps have made it more convenient and secure to pay for goods and services. And last one, health and fitness tracking. Mobile devices equipment with sensor and health app have made it easier for individuals to monitor their physical activities, track fitness goals, and manage their health. So, and there are many more. So, next thing comes like what is the need of memory management? So, memory management is essential for mobile devices due to several reasons. Uh, First of all, that is limited physical memory. Mobile devices typically have limited storage compared to traditional computers. So, efficient memory management ensures that available memory is used optimally, preventing slowdowns and crashes due to memory uses. And multitasking, mobile devices often run on multiple applications simultaneously. Proper memory management ensure that these applications run coexist without excessive consumption of memory and leading to a smoother user experience. And when we talk about performance, efficient memory management improve overall device performance. It allow applications to load faster, respond quicker, and reduce lag when switching between the tasks. And battery life mismanagement of memory can lead to excessive resource usage, draining the device battery faster. Well managed uh, memory help conserve power, thereby extend their battery life. And stability, memory leaks or insufficient memory allocations can cause apps to crash, leading to a less reliable user experience. So memory management helps to prevent these issues by reclaiming and recycling memory as needed. Background processes, some apps may continue running in the background and consuming memory even when not actively used. Memory management ensures that background processes are accurately managed to avoid unnecessary memory consumption. And resource allocation is like mobile devices may have various hardware components and features that require memory allocation. Proper memory management ensure that each component gets the necessary resources to function correctly. And last one, that is storage management. Mobile devices often use internal storage in form of virtual memory that is also called swap space. Efficient memory management involves managing storage and RAM simultaneously to maintain optimal performance. So there are many more. So overall, memory management is crucial for mobile devices to ensure smooth performance, stable operations, extended battery life, and a positive user experience in the face of hardware limitations and varying uh, application demand. So next thing that we are going to cover, that is what is the role of RAM in the mobile devices, or we can say in the memory management. So RAM, that is random access memory, plays a crucial role in how mobile application functions and operate efficiently on the mobile devices. RAM is a type of volatile memory that stores data and instructions required for the currently running processes. So here we are going to cover, few applications of RAM. First of all, application loading. When you launch a mobile application, it is loaded into the device RAM from the storage. Here I am storage, my main storage is internal memory or SD card. The application code, resources, and data are temporarily stored in RAM to execute the. And next one is active processes. As the application runs, RAM hold the data structure, variables, and resources needed for the active processes. For example, in the gaming application, RAM holds information about the game state, level progress, and correct attributes. And multitasking support, like mobile devices often allow user to switch between multiple applications quickly. RAM enable this by allowing the device to keep multiple applications in the memory simultaneously. When you switch between the applications, the active state of each app is stored in the RAM. So it aligns the smoother multitasking. Fast access RAM provides faster access to data compared to storage. Again, here storage means internal memory or SD card. Since RAM is volatile memory, it can be read and written quickly, make it suitable for storing data that needs to be accessed frequently. And next one, resource allocation. RAM is responsible for allocating memory to different applications and processes based on their priority and demand. And app performance, sufficient RAM is crucial for ensuring smooth app performance. If an application requires more memory that is available in the mobile, it may slow down or crash due to memory short. So inadequate RAM allow apps to operate uh, efficiently without significant performance issues. And temporary storage, that's mean like mobile application may use RAM to temporary storage like caching data to reduce the time. Cache data in RAM can be quickly accessed, improving app responsiveness. And next one is app switching. When you switch from one app to another, the current app data and state are temporarily stored in the RAM. This way, when you return to the previous app, it can resume from where you left off without having to start from scratch. And the last one here is app termination. If the application, sorry, if a mobile device runs out of available RAM due to multiple active applications, the operating system may close or force quit background applications to free up memory. So this helps maintain system stability and prevents complete device shutdown. So in conclusion, RAM is a critical component for mobile applications as it provides fast access to data, support multitasking, ensure smooth app performance, and allow for quick app switching. So having sufficient amount of RAM is vital to ensure a positive user experience and efficient operation of mobile applications. So for the same reason, RAM are extending uh, in the mobile market. So here is a graph how RAM is evolving time to time. So you can see in this particular graph, uh, RAM are increasing year by year or time to time, we can say. But you can, at the same time, you can notice one thing, uh, iOS RAMs is lower than Android one. So does it mean low amount of RAM is sufficient in iOS as compared to Android, or iOS manage RAM in proper manner than Android? So let's into it. So when it comes to memory management or optimization in RAM, Apple clearly takes lead here. So first of all, here is language differences. When a developer write an app for iOS, it compiled directly to the code that can run on iPhone processor. This is known as native code, as it does not require any kind of interpreter or virtual environment to run. Android, on the other hand, is different. Android use Java or Kotlin. When Java code is compiled, it's turned into an intermediate code that is called Java bytecode that is processor independent. So, uh, Android operating system and processor combination needs a runtime environment that is called JVM or Java Virtual Machine that understands Java bytecode and can convert it to the native code of the processor. So, in this way, RAM consumption is more in Android devices. Next one is hardware optimization. So hardware of Apple devices are specifically designed for high performance. The processor and RAM is not only factor to achieving the high performance, but the cache memory, bus speed, I/O buffer, microcontrollers, etc. all play the big role. And next one is stable RAM management. Apple uses a variety of practices to ensure greater RAM management. For example, on an iPhone, the system does not end a task after a short interval, but on Android smartphones, the default interval uh, to end the particular task is less by default. Okay. So this practice eventually creates system instability and higher RAM consumption. Because if you open any app again, the system would not be able to open it from RAM. And next one is background processes. In most of the cases, Android, uh, in most of the cases of Android, several OEM, that's mean original equipment manufacturer, provide customized operating system based on the unified uh, Android resource source code. And additionally, developers integrate a variety of unique functionalities such as pre-installed application and device-specific feature. So all of this lead to an increase in number of background processes and the consumption of more and more RAM. However, this is not the case on iOS devices. Apple iOS operating system is highly optimized and has tested countless times. Unlike Android, iOS limit the use of background processes in order to conserve battery life and improve the user experience. So let's see difference of few popular apps in terms of consumption of memory. So this one. So as you can see, the iOS app tends to less RAM. If you take an average, it is around 40% less RAM. This means if everything else is equal, the iPhone will need 40% RAM, 40% less RAM to hold the same number of apps in the memory as an Android phone. So if an iPhone has 6 GB, then a flagship Android device would need 8 GB to run the same application. Okay. Next thing that we are going to cover, that is as an application developer, how I can optimize memory. So here I will focus in terms of iOS applications. So first of all, here is retain cycle. Uh, an object is released when it does not have any strong reference. For example, when a view controller has a child view controller and has a strong reference to its child, and the child has a weak reference for its parents, then it's okay. But what if two objects point to each other with a strong reference? So in this case, they would not get released until the app is terminated. This is called retain cycle. Although we have a concept of ARC to manage memory in iOS, we can see memory leaks that as a developer we need to handle. And next one is timers. Timers class is a flexible way to schedule work to happen in future, either just once or repeatedly. So timers can create retain cycles, memory leaks due to not properly managed. So we can avoid retain cycle or memory leaks in timers in several ways, like we can use weak self or unknown self. Or second thing we can do, invalidate timers when they are no longer used. And next one is big images. So scale down images can significantly reduce the memory uses. Next one is cache. When caching storage get bigger, we might find ourselves dealing with memory issues. So while we cache the data, deletion of cache also need to handle. And lazy loading. Lazy loading means that you load the object into the memory only when we need. Besides saving memory, it also reduces the loading time and of the application and the screens. So next things that we are going to cover, that is how we can verify memory issues. So basically here are a few tools, or we can say concepts that that I have mentioned. Uh, First one is memory gauge. The memory gauge is located on Xcode. So basically, Xcode is IDE that is used for iOS to develop the iOS applications. It shows the app uses during the life cycle. Generally, you should look at the memory gauge when you run your application and try to pick up any weird behavior. So here, example of weird behavior might be if application is using high memory or memory consumption is continuously growing, or it can be like when you go to background and you should see the memory is reducing. If it is not, you should think of releasing a resource such as loading the big images or in order to stay in background and small uh, with the small memory footprints. That's the thing. So next one is instruments or memory profiling. I'm not going to explain how to use the instruments, but it is a low-level tool to identify both leaks and allocations in the app. Next one is deallocate or deinit methods. Every object has dealloc in Objective-C and deinit in Swift. So which is called when the object get released. So uh, this method. Implement this method and put a log or a background to verify that object is being released as you expect it to be. And next thing is unit test with memory metric. If you know that certain piece of code is generating high memory uses, it is best to measure it using the memory metric. And next one is simulate memory warnings. In the simulator, under the debug menu, you have an option simulate memory warnings. So you can use this to see what happens to your memory uses when it gets the memory warnings. And next one is memory debugger. At the bottom of Xcode, again, Xcode is a tool or IDE, we can say, that we use to develop the application. So there is an option debug memory graph where we can verify memory graph and see what is the status of memory allocations. So, and the last one, leak detection libraries. So there are several libraries available that can help to detect memory leaks. So next thing that we are going to cover, that is how memory managed internally. So memory management in mobile devices is handled by the operating system, which employs various techniques to efficiently allocate, use, and reclaim memory resources. So here are few concepts by which we can understand how memory is managed internally. So first of all, we have virtual memory. So when the RAM become inefficient to hold the active processes, uh, the operating system moves less frequent data from RAM to storage to free up the space and more critical processes. This process is also called swapping or paging. And next one is process isolation. So each running application is isolated from other application to prevent them from the accessing each other's memory space. So this isolation protects the integrity and security of each app's data and prevent conflicts. Memory allocation: when an application is launched, the operating system allocate a portion of RAM to it, known as processes address space. This address space contains the code, resource, and data required by the app to run. And low memory management: when device RAM is running low, the operating system may terminate background processes, clear cache data, or prompt the user to close the certain application to free up the memory. And page replacement: in the virtual memory system, the operating system use page replacement algorithm to decide which page means block of memory, to move from RAM to storage. And memory compactation: it is like to optimize memory uses and reduce the fragmentations. The operating system may perform memory computation, which rearrange memory to create a larger block of free space. So heap and stack. RAM is divided into two main areas, the stack and the heap. The stack is used to store local variables, function calls, information in last in, first out manner. The heap is used to dynamically allocate memory such as objects or array that have an indefined lifetime. And next one is garbage collector. It works for Android devices. A garbage collector periodically identify and free up memory occupied by the object that are no longer in use. This prevents memory leaks and ensure efficient memory utilization. And next one is ARC. ARC stands for automatic reference counting, and it's a memory management feature in iOS. So this automatically manages memory in terms of allocation and deallocation of objects. Uh, so basically, broadly, we are going to discuss heap and store, stack allocation, garbage collection, and ARC. The specific memory management techniques may vary based on the mobile operating system and the device hardware capabilities. The goal is to ensure efficient use of available memory, provide a smooth user experience, and prevent memory-related issues like crashes and slowdowns. So let's see how stack memory allocations happen. So whenever a function is called, it gets variable. So its variable gets memory allocated on the stack. And whenever the function call is over, the memory for the variable is deallocated. Uh, this all happens due to some predefined routines in the compiler, right? So a programmer uh, does not have to worry about the memory allocation and deallocation of stack variables. And in iOS, uh, other than function call, structures and enums get memory in the stacks. So here you can see I added an example like here is a method that has a variable a and it's calling another method b. So how the memory allocation is happening? So a frame is created for method a, variable b, variable a also a sorry variable a of method a will also created in the same frame. As method a calls method b, a separate frame for method b is created on the top of the first one, right? So variable v of method v is also created in the same frame. So whenever the call is over, this frame will be deallocated from the memory. Okay, so let's understand how the heap allocation happens in Android devices. So, right. Whenever we created any Java or Kotlin object, this will be allocated in heap memory. To handle heap memory, to handle or manage heap memory, we have a garbage collector in Android. So, so basically, here are three phases in which garbage collector works. First of all, it identifies the live objects in the memory and mark them. After that, it delete all the unreferenced object from the memory, and in the third process, it compact the free space that comes due to deletion of unreferenced object. Yes. So basically, heap structure is divided into three categories. These categories are young generation, old generation, and permanent generation. So let's discuss one by one. First of all, young generation. This is where all the new objects are allocated and aged. So what is the meaning of aged? We will discuss it later. So this generation is split again into two parts, that is hidden space and survivor space. S0 and S1. So uh, what is actually add-on space? All the new objects are allocated here. Once the space is full, minor garbage collection will be triggered. So actually what minor garbage collection is, uh, whatever garbage collection process happens in young generation, it will be minor garbage collection process. So when the garbage collection is triggered, it first mark all the live objects in the hidden space, then move them uh, into one of the survivor space. Thus, hidden space is cleared so that new objects can be allocated there again. So let's discuss this in the detail. Yes. So here is the diagram. Here we can see how the minor garbage collection process happens. So first of all, you can see here is the hidden space, and this is S0 and S1 survivor space 0 and 1. First of all, new objects will be allocated in the hidden space. Whenever this particular space, I mean hidden space, will be full at as this stage it is full, marking will be start. So garbage collector mark all the live objects and flush out all the unreferenced object. Then it will move a live object from add-in space to S0, any survival, that means survival space 0. So whenever there is one switch, the age of any particular object will be 1. So here you can see the age of these objects is 1 here. Now add-in space is clear and we have two live objects in S0. Now again add-in space will start to fill. Whenever it will be filled, again marking will be start, and it will mark all the live objects. So here is one thing. Now marking will be in hidden space and S0 both. And whenever the marking will be completed, unreferenced object will be flushed out, and reference object will move from S0 to S1 and then hidden space to S1. In this case, you can see the aging of this object will be 2 as it is switched 2 times, and aging of this object will be 1 and it is just switched single time. So again the same process will start, and then space will start filling by the new objects, and marking process will be there. uh, in the next case, you can see at diagram number 11, the live object will move from S1 to S0 and add an space to S0. And in this case, you can see like uh, age of this object is 3 and age of this object is 2 and age of these objects is 1. So this process will continuously happens until uh, age of the particular object reach to the threshold point. We can suppose we consider threshold point here 9, so it will move 9 times. And whenever the if switching will be 9 times, its age will be 9, then it will move to old generation. So this is the whole process in which it works. So now let's discuss about the old generation and permanent generation. So yeah, old generation memory contains the objects that are long lived and survive many times, many rounds of the minor garbage collector. Usually, garbage collection is performed uh, in the old generation when it is filled, right? So, old generation garbage collection is called major garbage collection and usually takes a lot of time. And if we talk about the permanent generation, the JVM keeps the track of loaded classes metadata in the permanent generation. Additionally, the JVM store the static constants in the memory section. This include all the static methods, primitive variables, and the reference of the static objects. So let's move further. So how the memory allocations happens in iOS in case of heap memory. So whenever we create an instance of a class ARC, allocate a chunk of memory to store the information about the instance associated with its type and value. And when the instance is no longer needed, ARC free up the memory used by that instance. Yeah. ARC basically use the concept of reference counting. Let's understand by with an example. So here I created a class person and created three more variables with person one, two, and three. First of all, I created the object of person one. Here its reference count will be one. And now I assign this object to another variable, person two. Now reference count will be two. And I again assign this particular reference to another variable, and that is person three. Reference count become three. As soon as I assigning nil to person one, reference count will be two. And I am assigning nil to person two, reference count will be one. I mean, it will be in the decremented order. And as soon as I assign nil to person three, reference count will be zero. That's mean this particular object will be deallocated, right? And lastly, we are going to cover as a end user how we can uh, manage memory of our devices. So here are few practical tips that I have mentioned. So first of all, close unused applications. So users should close applications running in the background that are not actively using. Background apps consume system resources and memory. So slow down the resource devices. And manage this, limit the number of visits on the home screen. Uh, while visits can be convenient, but they also consume memory and resources. Users should only keep the ones they use frequently. Next one is clear cache and temporary files. Cache data and temporary files can build up over the time, taking up valuable memory. Users should regularly clear cache and temporary files for apps they use. And next one is update your apps and OS. Advise users to keep their apps and operating system up to date. Developer often release update to improve performance and the memory usage. Okay, limit background processes in the developer option available. So basically, it is available in the Android devices. User can limit number of background processes allowed. This prevents excessive apps uh, from the background simultaneously. Use light version of apps suggested. Using a light version of popular apps if available. Light apps are designed to use less memory and data. And uninstall unnecessary apps. Users should remove apps that are no longer in use. Unnecessary apps take up storage space and can impact device performance. Right. So use cloud storage instead of storing all files and media in the device. User can use cloud storage service to keep their data accessible without taking up internal storage. So next one is manage photo and videos. Photo and videos can quickly consume storage space. So users should regularly backup media to the cloud and transform them to a computer, then delete them from the devices and optimize browser history. Browsing can accommodate a significant amount of data and cache. So users should periodically clear their browsing cache and limit the number of open tabs. Reduce animation and transitions, minimize the use of complex animations and transitions in the device setting. While visually appealing, they can slow down the system and consume memory. And next one is restart the device. Sometimes a simple restart can help free up memory by closing unnecessary processes and clearing the RAM. And use memory management app. Recommended reliable memory management applications that can help user identify memory hungry apps and optimize system performance. Avoid live wallpapers. Suggest using static wallpapers is instead of live wallpapers, as live wallpapers continuously run in the background and consume resources. And last one, monitor battery life. That is, user can significantly improve memory management on the mobile devices, uh, so resulting in better overall performance and smoother user experience. So I think that's it from my side. So if you guys have any question, so
Yes, Munish, I've pasted it in your chat. We have three questions. I've put two for you, and I'm putting one more.
okay. Uh, So question is sometimes for everyone, Android phone manufacturers suggested clearing the memory while Apple suggests keeping the apps uh, in memory. Something for everyone. So this is second question, right? Uh, Something for everyone, Android phone manufacturers suggest clearing the memory while Apple suggests keeping the apps in memory. So the reason behind it might be like iOS is more capable to handle the memory management as compared to Android one. So this might be one of the reason. So and other thing is like what is the difference between paging and virtual memory? So RAM is a limited resource, whereas the most practical purpose virtual memory is unlimited. So there can be many processes. Each process has its own 2 GB of private virtual address space. Uh, Next one, Android have cache clearing options, but iOS does not. Why? So it is related to first question, I think.
That's it, Munish. Those were the questions that we had.
Okay. So thank you all for your precious time. And if you have any other doubt, you can connect me with my email ID manish.kumar@encora.com. Thanks a lot.
Thank you, Munish, and thank you everyone who joined us today. Thank you so much.